Namaskar. Again, welcome to my YouTube channel, that is Simple Concept. I am Dr. Tapan Kumar Sankar, again coming with a new topic, that is the shape of atomic orbitals. So today we discuss the shape of molecular orbital in chemistry. So basically, in this video, we have know about the introduction of atomic orbitals, shape of atomic orbitals, s orbitals, p orbitals, d orbitals, and f orbitals. And in last we introduced some animated video. That means you have to clearly seen that how actual the molecule will be formed. So atomic orbitals is basically is a very teeny particles. So if you see with the help of quantum chemistry, it is like just dot. You see here in pictures, you see so many dotted particle is there. Actually, these are the positions where the electron probability. So where the high probability of electron is possible, that is actually called the shape of orbital, and basically it is called the atomic orbital. So today in this class, we have to discuss about how the atomic orbitals actually show and what is the basic fundamental principle of atomic orbital. So basically the shape of atomic orbital S, P, D and F. S means the sharp, P means principal, and D means diffuse, and F means the fundamental. S orbital is sharp and spherical in shape. As you see in screen, the S orbital just like the ball. And the P orbital, that is the principal orbitals, is denoted by the P, and it is like the dumbbell in shape. And if you think D orbitals, that is diffuse orbital, double dumbbell in shape. And if you're talking about F orbital, it is very difficult to explain in terms of F orbital in 3D model also. So here, next you see in screen, each and every orbital are basically in the coordinate Cartesian like x, y, z. So in next slide we will discuss how s orbital lie, how p orbitals lie, and how d orbital lie in a coordinate x, y, and z. So s orbital, there is no effect of any coordinate like x, y, z because it is spherical in shape. So it is simply look like a ball. If you see in screen, it is simply like a ball. And here, one nucleus is always present in the center of s orbital. And here you see in screen that is look like the ball. That means the electron probability is high in this region. That's why it is spherical in shape. Then this is the systematic diagram of 1s orbital. If you're talking us about the 2s orbital, then you have to see some circle in this area. This is the node. Node means that where is the electron probability is zero. So where the electron is not found fundamentally, this is called the node. And apart from the other area where the electron is found, this is like orbital in this shape. And this is the systematic diagram of 2s orbital. Like that, in 3s orbital, there is two node is present, 1 and 2. So here the electron probability is 0. That is called node. So this is the systematical diagram of 3s orbital. If you see the quantum chemistry, with the help of quantum chemistry, you clearly see that the electron nothing but a dot, and the where the dot is high, that is probability of electron is high, it is orbital, and where there is no probability of electron, it is called node. So this is the systematic diagram of 1s orbital, 2s orbital, and 3s orbital. Then we have to talking about the p orbital. This I am earlier told that the p orbital is like dumbbell in shape. So basically, it is depend on the coordinate like x, y, z. There are three type of p orbital, like px, py, and pz. You see here, here is also one nodal plane, because actually we have seen that the p orbital is dumbbell in shape, but it is not true. We if you're talking about with the help of quantum chemistry, you see two balls like structures are joined somewhere, and this balls like structures look like the dumbbell in shape, and in between these two lobe, so there is uh, no probability of electron, so it is called the nodal plane. You see pxy, the lobe is present in p axis, and in between the p axis there is one nodal plane, that is plane where the electron probability is zero. Similarly, like 2py, the lobe is lie in a p axis, and the plane who bisect the two lobes. And similarly, if you're talking about the 2pz, 2pz is also same. The lobe is lie along z axis. Now, this is the actual figure of p-axis, where the some dense dot present in y-axis above and below, and in the middle line there is no electron probability, so it is called the nodal plane. So this is only for the 2px, 2py, and 2pz atomic orbital. If you're talking about the different shells atomic orbital like 3p, 4p. So we have here, we have clearly seen that the nodal plane is also present in between the lobe, just like s orbital. So this is basically for the fundamental structures of p orbitals. Now we talking about d orbital. D orbital is a double dumbbell in shape. You see there that two four lobe is there. That's why it is called double dumbbell in shape. So if we just consider the 3D structures of the d orbital, you see first we are talking about the 3dxy. Here two plane is there and four lobes. Two lobes are intersected by the one plane, and another two lobes are intersected by another plane. So this is the 3dxy. Here the lobe in between x and y axis. Just like first one, if you see 3D XZ, it is also the two planes bisect the four lobes, and the lobes are present in between the XZ axis. So basically, this is the structure of 3D XZ. And again, we are talking about 3D YZ. Here is similar like the first and second one. The lobe, four lobe are intersect by the two planes, and the lobe is lie between the Y and z-axis. These three orbitals are almost similar because their their lobe exist in between their two axes. But if you're talking about the 3D x square and 3D y square, the scenario is different. In this orbital, in this d orbital, the four lobes are lie in between x axis and y axis, and intersect are the same, like one plane is intersect to this and one plane is intersect to this. And another, the last type of d orbital, you see 3dz square. This is in between. Is it difficult to understand actually what is the 3 dz square? If you see that here, one is funnel, like upper one funnel is open, and in the uh, lower part is one funnel. Basically you see the cone like structures there, and the lobe is in between z axis, and the one circle made by the lobe, this is in between the x and y axis. So basically these are the principal structures of d orbital. And actual, if you see the d orbital, it is looking like this quantum dot with the four lobes. Now talking about the f orbitals, so it is very easy to explain s, p, and d orbital in 3D model and 2D model, but it is very difficult to explain uh, F orbitals in 3D model also. So it is very much confusing if you explain in a paper and a pen through the d orbital, through the F orbital is very difficult phases. So here we playing some videos, so you're able to understand the originality of actually the atomic orbital is there. So you see one video is I'm playing some video. So here we actually see how the molecules look like. So you see in the videos there is one electron around the nucleus. So basically it is rb, their nucleus is r means radius and b. So rb the radius, and you actually see see here x-axis, y-axis and z-axis. The electrons is like dot, so it's spread just like the universe. So after some time you will see the dense dot of electron, that is called the actual orbital. See, so basically first we have to see that the purely 1s orbital there is no node is present. Now if we talking about the two ways, then what is the scenario of that we will see in a video. क्या भी होने वाला है बस. See here, here is a one nodal plane is there where the electron probability is zero. So basically this is the structure of 2s orbital. So how this dense area, and apart from this in the middle there is some radical node where the electron is not present, and this one also the probability of finding electron is high. You see here the two lobe are present in between. If you're talking about the px axis, then two lobe is present here in x axis. Now, See here, you actually this is very dense. So here two radial node is present in between this lobe. So this is basically for 3s model. Let's see for the next. This is C 3p. 3p means 2p is the clear lobe, and in 3p there is also some nodal area is there where electron is not present. So in this two dense area there is one little bit dense, or you can say that it is somewhere where there is no electron is present. So this is the nodal area of electron. So here clearly see that the 3p orbital which is lie on z-axis, and one here is the actual the p orbital c. Here the electron density is high, here is also high, here is somewhere the electron density is come, that is nodal plane is present. Yeah, interesting. Yeah, interesting to see here the d orbitals. There, these four lobes are present. You see in the screen very beautiful color, and the four different lobe is there. So this is basically the probability of electron is high in this four lobe, and you see the picture is very interesting how the electron exists in d orbital. Now see the higher orbitals. How look higher orbitals like F orbitals in a real way. See here, one, two, three, four, five, six different lobes there. So it is very difficult to identify the F orbital. That's why I'm saying that it is not much easy as d orbital or p orbital and s orbital. Let's see the videos how looks the F orbitals actually. Thank you watching my videos. If you like this informative about the orbital, atomic orbital, please like and share my YouTube channel. That is simple concept. Thanks once again.